Hi everyone, welcome to Real English,
where you learn natural English for real life.
I am Paul.
And I am Emily. Let us get started.
Today, we are going to tackle a scenario that tests both your technical expertise and your leadership skills. We are talking about the technical review meeting.
This is a massive milestone for any professional. You have done the research, you have crunched the numbers, and now you have to present multiple options to the decision makers and tell them which one to choose.
It sounds straightforward, but it is actually a communication minefield. When ESL learners have to compare two complex technical solutions, they often default to just reading a list of pros and cons. They say, option A is cheap but slow. Option B is fast but expensive. What do you think?
And that is exactly what you should not do. If you just hand the decision back to the client or the manager, you look like a researcher, not a leader. They hired you for your professional judgment. They want you to tell them what to do.
Exactly. When you present technical alternatives, you have to guide the room. You have to frame the comparison in a way that makes your final recommendation seem like the only logical choice. And today, we are going to teach you exactly how to do that using a highly effective communication framework.
We call it the C.A.R. method, C.A.R. It will keep your presentation completely on track.
Let us break that down. The C stands for context. Before you even mention the two options, you have to remind everyone what the actual goal of the project is. You establish the baseline.
Right. You say, to remind everyone, our primary objective here is to maximize energy efficiency while staying under a strict budget constraint. By starting with the context, you create the rules for the comparison.
Exactly. Then we move to the A. A stands for alternatives. This is where you introduce the options, but you do not just list features. You compare them using the concept of trade-offs.
A trade-off is a compromise. You say, Alternative 1 offers a lower upfront installation cost, but the trade-off is a higher maintenance requirement down the line. You are showing them the balance of the decision.
And finally, we reach the R. R stands for recommendation. You must own the final decision. You do not ask them what they want. You state your professional conclusion confidently.
You say, based on the life cycle analysis, I strongly recommend we proceed with the second alternative.
Context, alternatives, recommendation. The C.A.R. method turns a confusing data dump into a persuasive, strategic presentation. But to really sound like an industry expert, we need to upgrade your vocabulary. Let us open up the toolkit with our 5 pocket words for today.
Word number 1 is a noun, footprint. We are not talking about a shoe print in the dirt. In engineering and business, footprint refers to the physical space a piece of equipment takes up, or its environmental impact.
You can say, the first heat pump system is highly efficient, but it has a massive physical footprint that our current facility cannot accommodate.
Word number 2 is a compound noun, life cycle cost. This is crucial for any technical pitch. It means the total cost of owning something over its entire life, including buying it, running it, and repairing it.
You say, option A is cheaper today, but option B has a significantly lower life cycle cost. Managers love hearing about life cycle costs.
Word number 3 is an adjective, optimal. It means the best or most favorable situation. It sounds much more professional than just saying the best one.
You do not say, this is the best choice. You say, under the current site constraints, this configuration is the optimal solution.
Word number 4 is a noun, redundancy. In daily life, redundancy means something is unnecessary. But in engineering and IT, redundancy is a very good thing. It means having backup systems in place so if one fails, the operation does not stop.
You say, for a critical municipal project, we must choose the system that offers built-in redundancy to prevent total shutdowns.
And word number 5 is a fantastic transition phrase, to weigh against. It means to carefully consider the importance of one thing compared to another.
You say, when we weigh the upfront investment against the long-term energy savings, the second option is the clear winner.
Footprint, life cycle cost, optimal, redundancy, and weigh against. Use these words and you will instantly command the room during your next design review. Now, let us step into the Smooth It Out clinic to fix those awkward translation habits.
Let us start with how people introduce the options. A learner might look at a slide and say, I have two things to show you today. Here is the first one, here is the second one.
That is far too casual for a boardroom. Smooth it out and sound like a consultant. You say, I have evaluated the site requirements and narrowed our focus down to two viable alternatives.
Two viable alternatives. That sounds incredibly sharp. Now how about comparing a negative point? A learner might say, the bad thing about option A is that it uses too much electricity.
Bad thing is not a professional term. We use our pocket words. You say, the primary drawback of alternative A is its high operational life cycle cost.
What about making the final choice? We talked about this earlier. A learner often finishes their presentation by saying, so, these are the two options. Which one do you want me to do?
You are surrendering your authority when you say that. Smooth it out and make a firm recommendation. You say, having weighed both options, my professional recommendation is to move forward with alternative B.
And if they ask you why you chose it, do not just say, because it is better. You say, because it provides the optimal balance between performance and budget.
Excellent upgrades. It is time to put all of this into action. Let us move to the main event, the practice conversation.
The scenario is this. I am a senior system design engineer. Emily is the project director and the primary stakeholder. We are currently reviewing the engineering designs for a massive new municipal water treatment facility.
This is a critical infrastructure project, and we cannot afford any mistakes.
Exactly. My specific task for today's meeting is to present a technical comparison of two different heat source solutions for the water plant's main processing environment. I need to explain the pros and cons of each heat source, and ultimately get Emily to approve my recommendation so we can move to the procurement phase.
I will play the role of the serious, analytical project director. Pay close attention to how Paul does not just read a list of facts. He uses the C.A.R. method to guide my thinking, and he uses our pocket words to build a bulletproof argument. Here we go. Good morning, Paul. I have your executive summary in front of me regarding the thermal dynamics for the new water facility. I know we have been struggling to finalize the main heating architecture. Walk me through what you have found.
Good morning, Emily. Yes, the heating architecture has been a complex challenge due to the specific site constraints. To provide some quick context before we dive into the schematics, our primary objective here is to secure a heat source that guarantees absolute operational stability for the water processing, while keeping our total energy consumption within the municipal budget limits.
Exactly. If the heat source fails during a winter freeze, the entire water plant goes offline, and that is a PR disaster we cannot afford. So, what are we looking at?
I have evaluated a dozen different configurations and narrowed our focus down to two viable alternatives for the primary heat source solution. Alternative A relies on a traditional centralized commercial boiler array. Alternative B is a modular, industrial-grade water source heat pump system.
Okay, a boiler array versus a modular heat pump system. Let us hear the comparison. What are the trade-offs?
Let us start with Alternative A, the centralized boilers. The main advantage here is a very low upfront capital cost, and the technology is extremely straightforward. However, the trade-off is significant. It relies heavily on natural gas, which exposes us to volatile fuel prices, and it has a massive physical footprint. It will take up almost 20% of our available basement square footage.
Losing 20% of the floor plan is a tough pill to swallow. We need that space for the secondary filtration units. What about the heat pump system?
Alternative B, the water source heat pump, uses the ambient temperature of the facility's own treated water to generate heat. The immediate drawback is the upfront cost. It is about 30% more expensive to install than the boilers.
30% is a massive jump, Paul. I am going to have a hard time selling a 30% budget increase to the City Council.
I anticipate that pushback, Emily, but we have to look at the lifecycle cost, not just the installation invoice. When we weigh the upfront investment against the long-term efficiency, the heat pump system pays for that 30% difference in just under 4 years through electricity and gas savings.
A 4-year ROI is compelling, but what about the stability issue? You mentioned winter freezes. Can a heat pump handle the peak load during a severe drop in temperature?
That is exactly why I am favoring the modular design of Alternative B. Because it is modular, it provides built-in redundancy. If one compressor unit requires maintenance, the other units automatically scale up to carry the load. With the centralized boiler, if the main burner goes down, the entire plant loses heat. The heat pump guarantees the water plant stays operational.
Built-in redundancy. That is exactly what I need to hear to reassure the board.
Therefore, having weighed both options against our core objectives, my professional recommendation is that we proceed with Alternative B, the modular heat pump system. It presents a higher initial cost, but it is unequivocally the optimal solution for long-term stability and life cycle efficiency.
You have made a very clear case, Paul. The redundancy and the smaller physical footprint solve two of my biggest headaches on this project. Let us go with your recommendation. Draft the formal specification sheet for Alternative B, and I will present it to the Council on Thursday for the final budget sign-off.
Understood. I will have the technical specs on your desk by tomorrow morning. Thank you, Emily.
And scene. Paul, that was a masterclass in managing a technical review. You led that entire conversation from start to finish.
It is all about the structure. I used the C.A.R. method right away. I started with the context, reminding you that our goal was stability and budget. That set the stage. Then I presented the alternatives, focusing on the trade-offs like the physical footprint and the upfront costs.
And when I pushed back on the 30% price increase, you did not get nervous. You immediately pivoted to the life cycle cost and the ROI. That is how you speak to management. You translated an engineering problem into a financial benefit.
And finally, I made the recommendation. I did not ask you to pick one. I confidently stated that Alternative B was the optimal solution because of the built-in redundancy. I made the decision so obvious that all you had to do was agree with me.
That is the secret to a great presentation. Your vocabulary was also incredibly sharp. You talked about viable alternatives, physical footprint, life cycle cost, redundancy, and the optimal solution. When you use that level of English, nobody questions your technical expertise.
For all of our listeners who are engineers, architects, or project managers, you have to stop just presenting data. You have to start presenting decisions. Use this framework in your next meeting and watch how much more respect you command from your stakeholders.
Take ownership of your expertise. Thank you so much for joining us for this advanced communication strategy session on Real English.
Keep practicing those recommendations. Never leave the decision hanging in the air. And we will see you next time. Bye, everyone.